Today on How It's Made Dream Cars, the BMW i8, a plug-in hybrid that drives like a supercar. The BMW headquarters, known as the Four-Cylinder, has been a landmark of the Munich skyline since its construction in the 1970s. The bold architecture of the building embodies the company's emphasis on innovation and efficiency. The building houses a multifunctional exhibition space called the BMW Welt. It's where visitors can get a first-hand look at BMW's latest products like the i8. Most electric vehicles are just gas-powered cars retrofitted with batteries and electric motors. The slogan for BMW's i-Series is Born Electric, because these cars are built for electrified drivetrains. With gull-wing doors and the ability to accelerate from 0 to 60 in just 4.4 seconds, the BMW i8 looks and performs like a high-end sports car. The BMW i8 achieves its astounding fuel economy thanks to a powertrain that combines a highly efficient three-cylinder gas-powered engine with a starter generator and electric motor. The starter generator works with the twin-power turbo engine to drive the rear wheels. BMW calls this system eDrive. The powertrain can crank out 357 horsepower. BMW chose to develop the entire powertrain in-house for the i8. An electric motor consists of an interior housing, stator, and a rotor. The stator is fitted with copper windings, placed in a series of phases around the diameter. A device called a coil winding and inserting machine winds 12 coils of copper at a time for a total of 24 coils. Each motor gets over a mile of wound copper. To maximize quality and performance, the wires must be as close to each other as possible. A robot transfers the stator to a station, where the copper windings will be installed. BMW is able to make their motor unusually small, thanks to a specially designed winding configuration. This saves space while helping the car maintain a low curb weight. The copper in an electric motor must be wound as compactly as possible. To ensure this, manufacturers use a highly specialized sewing machine to bind the wires tightly together with 45 feet of cord. BMW's goal is to make every aspect of the i8 as efficient as possible. Thanks to the plug-in hybrid system, the car can travel up to 23 miles on electric power alone. A forming machine uses clamping jaws to manipulate the top of the stator into the correct shape. This helps make the copper coils, insulating paper, and binding cord as tight as possible. Before the stator reaches this station, workers have already inserted each bundle of wires into a color-coded sleeve. Each of the three colors, red, black, and white, identify a different set or phase of the copper coils in the motor. Next, the stators are heated to 329 degrees. Then a robot lowers them into a vat of resin. It's very important that the components of the stator remain as rigid as possible. Coating the stator in resin helps hold everything in place, maximizing the motor's efficiency. The motor has to be as efficient and powerful as possible to boost the 3-cylinder engine and give the vehicle the power output of a supercar. Next, a team of robots build the rotors. They are composed of 6 discs. Each disc has 12 small magnets and 12 large ones. The completed rotor will have a total of 144 magnets. The robots offset the magnets as they insert them into the discs, creating a seamless transition between magnetic fields. This is so the motor will run smoothly. Once the robots have aligned the discs and joined them together, they are heated to 150 degrees in an oven. Heating the discs expands the central bore, making it easier to insert the rotor shaft. The rotor shaft has been cooled with liquid nitrogen to negative 190 degrees. The stator, rotor, and the inner and outer housing come together to form the motor. BMW calls this the E-machine. A technician works with a robot to install the power electronics on the finished E-machine. This work is carried out at 4 different assembly stations. The stations are designed according to BMW's slogan, "Today for Tomorrow." Because of Germany's aging population and diminishing pool of skilled laborers, BMW has begun to create stations that can accommodate workers of older ages. The workstation is ergonomically custom-tailored to each and every worker. A technician can adjust the robot to his or her individual working height, or alter its position while working on the bottom or sides of the E-machine. BMW has created a special structure for their I-Series called LifeDrive. BMW claims this is the first vehicle architecture designed specifically for electric cars. Assembly of the i8 takes place in Leipzig, Germany. BMW has 30 production facilities spread throughout 14 countries. The Leipzig plant specializes in building the company's lightweight cars that have alternative drive systems. True to its innovative focus, the plant has 4 wind turbines that produce a total power output of 10 megawatts. That's more than enough power to produce the company's electric cars. Here, technicians are putting together the rear drivetrain unit. They start by lowering the 3-cylinder engine onto a purpose-built aluminum frame. Built at BMW's Hams Hall plant in the UK, the engine features the company's proprietary twin-power turbo technology. The engine is capable of producing 231 horsepower. Next, the workers install the car's rear braking and suspension system. The rear chassis technology includes a 5-link rear axle with aluminum components engineered for optimal weight and strength. This, along with the double wishbone axle in the front, allows the i8 suspension to provide an extremely smooth ride. To complete the rear drive unit, technicians install a sound absorber. BMW's assembly of the i8 features parallel steps along a single assembly line. One team builds the rear drive unit, while the other team focuses on the front and passenger modules. A portion of the car's drive modules are made of aluminum. This helps reduce the i8's overall weight. The electric motor is directly connected to the power electronics, cutting down on wiring and weight even further. At this station, workers finish assembling the front axle with the car's electric motor. The electric motor develops power as the car accelerates. This motor is specially designed for the I-Series. It features optimized arrangement and dimensions of the torque-producing components. This powerhouse generates something called reluctance torque, which allows it to continue churning out torque at high revs. No electric vehicle is complete without the all-important battery. The i8's high-voltage lithium-ion pack runs down the center of the car. It has a gross capacity of 5.2 kilowatt-hours and direct refrigerant cooling. The highly specialized packaging and assembly of the battery requires more than 20 robots and 400 assembly steps at the BMW plant in Dingolfing, Germany. The rear drive unit arrives with its 3-cylinder engine. The drive unit features precision direct injection, turbocharging, and variable valve lift control. It has the highest output of any engine produced by the BMW Group. Workers assemble the fan rotor, water cooler, and climate condenser of the cooler unit. They connect all the remaining cables and feeds. This finishes the assembly of the drivetrain module. Here we see the completed drive element of the LifeDrive architecture. With an intelligent energy management system, the i8's drivetrain can produce a remarkable blend of power and efficiency. All of the drive components are securely housed in the lower section of the i8, so there's no transmission tunnel running through the center of the car. This leaves more room for the passengers up above in an area that BMW likes to call the Life Module. BMW calls the passenger area of the car the Life Module. It's made of carbon fiber reinforced plastic, or CFRP. This material is 50% lighter than steel and 30% lighter than aluminum. Technicians move the CFRP Life modules forward on the production line to prepare them for installing the wiring harness and dashboard. The cockpit of the i8 has a multifunction display that can be tailored to the customer's specifications. The instrument panel display changes depending on the driving mode, featuring 3-dimensional graphics and dynamic range display. It even has graphics that help the driver with charging the car's battery. A worker installs the brains of the passenger compartment, the body domain control unit. There's a lot to keep track of in the i8, from the heated seats and mirrors to the rear view camera. The airbag control unit is hidden inside the center console. The BMW i8 comes with front, side, and head curtain airbags, as well as inertia reel seat belts with belt force limiters, and ISOFIX child seat attachment points. Workers install the windshield. Robots have already prepared it with a defined bond seam. The i8 is the first production car to feature chemically hardened glass. It's a product mostly seen on smartphones. Acoustic sheeting sandwiched between 2 layers of ultra-thin hardened glass results in a material that's 50% lighter than conventional laminated glass. Technicians attach the front section of the Life module with just 8 screws and adhesive bonding. The Life module includes a crash-activated aluminum structure that distributes the force of impact. This contributes to the i8's excellent safety rating. The carbon fiber reinforced plastic of the passenger cell plays an important role in the car's overall safety rating as well. The outer skin of the gull wing doors is made of aluminum, and the inner structure consists of CFRP. BMW was able to design very large door openings because of the remarkable strength of the CFRP. CFRP has a lattice pattern. Technicians can work it almost like a textile before it's injected with resin. With careful positioning of the fiber, they can create an incredibly lightweight material that's as durable as steel. Technicians now raise the life cell in order to install sound and thermal insulation materials. Sound is an important factor in the i8. BMW chose specific building materials for their lightweight and sound-absorbing properties. The car is already quiet thanks to its electric motor. It can power the car in a nearly soundless all-electric mode. The passenger cell is ready to meet its drivetrain. Technicians bring the two main elements of the car together to unite them into a single car. They bolt the two modules together with just 22 screws. The battery is placed beneath the passenger cell, giving the i8 an extremely low center of gravity. This, together with the car's carefully calculated 50-50 weight distribution, contributes to a precision driving experience. The fact that you can plug the i8 into a conventional wall socket to charge up its battery makes it a truly unique car, one that balances environmental concerns with the need for speed. In addition to all its cutting-edge innovations, the i8 is still a BMW. Its interior upholstery, exterior paneling, and wheels evoke the company's signature look. The motto of the i-Series is intelligent lightweight design. The bulk of the i8's exterior paneling is made of molded thermoplastic, an extremely lightweight, rust-free material. Only the hood and outer skin of the doors are made of aluminum. The i8 achieves an impressive drag coefficient of 0.26, thanks to features like an air flap control system, a sealed underbody, contoured side skirts, and air ducts between the rear lights and roof frame. The i8 comes standard with 20-inch forged aluminum wheels. But customers can choose from a variety of options, including mixed sizes for the front and rear. The tires have been optimized for aerodynamic efficiency. Their low rolling resistance means the car needs less energy to move. Once the wheel installer has finished, a second technician scans a barcode on the wheel to record that this task has been completed. And with that, the car slowly touches the ground for the first time. With the help of a hoist, workers lower the hood in place. The hood features the V-shaped beginning of the i8's signature black belt. This belt extends back over the roof to the rear section of the car. This BMW i8 is finally ready to roll. A worker tries out the steering and drives the car to the final testing stations, where technicians check that the car meets all the required parameters. In true sports car style, the driver and passenger sit low in the i8 seats. Exposed carbon fiber around the open door frame is a reminder of the car's lightweight construction. The center console houses the gear selector, iDrive operating system controller, start-stop button, and the driving experience control switch. In addition to the i8's high-voltage lithium-ion battery, it also has a 12-volt battery found in conventional cars. It's time to charge it up. The driver uses a BMW-designed option called a wall box. This device can charge an empty battery to 80% of its capacity in less than 2 hours. BMW offers a package called 360 Degrees Electric that includes wall box installation and maintenance. The package also includes bespoke mobility services that links the owner's digital devices to their car. This allows for data transfer between car and driver, making it possible to perform functions like remote battery charging. For the upholstery, they use olive leaf extract to tan the leather. This method creates none of the environmentally damaging waste that conventional tanning methods do. This is just one more example of BMW's objective of creating a truly eco-conscious vehicle, the sustainable supercar.